Okay, so the way we did that, like I said, you select all of this, you go to the formulas tab, then create from selection. So once you've done that, you need to type in the equation. So this column here is for the analytical solution. So for the analytical solution, this was the equation we arrived at. So we need to represent it in a way that Excel will understand. So let me go back to the notes. So this was the analytical solution we arrived at. This was the analytical solution we arrived at. But in Excel, this is the way we write it. M multiplied by G divided by CD. So we assigned CD instead of C. We said let the coefficient be CD. Then multiplied by 1 minus exponential. So in place of this exponential, this is the word we use, the keyword we use. Then minus C divided by M, then multiplied by T. But in this case, we used a column on the Excel table to specify C. So let me go back to the Excel sheet here. So instead of T, I just say use the value at A9. So that's why it's A9 here. Then for this is A10. Use A10. For this is A11. For this A12 and that. So this is how you solve it in Excel. Now we want to solve it using numerical solution. So using the numerical solution is going through the Eulers method. And we need to program in order to write the Eulers method. So this is the part where you guys have to really pay attention. So in order to compute the numerical solution, the analytical solution is actually very easy to do. But like I told you, the analytical solution may not even exist, or it may be very complex to calculate. The reason why we're able to solve this model analytically is that it's a very, very simple model. It's very, very simple. That's why we managed to solve it analytically. But for most engineering problems, you might not even be able to solve it analytically. So you have to go through the numerical solution. So that's why we need to do the numerical solution. In order to do the numerical solution, we need to write a function in Excel to compute the numerical solution for us. We need to write a function that is going to do that. Then in order to do that, in Excel has a place where you can write the code. So please pay attention while I do this. So in order to write the Eulers method or the Eulers function, in order to calculate the numerical solution for this problem, first of all, in Excel, you go to File, then under File, you will see the options. Then you click on the options. Then when you click on the options, a new window is going to appear. A new window is going to appear. Can you all see the new window for the Excel options? I want to be sure that you guys can see the window. Okay, thank you. So when you get to that window, because we want to write a code. So when we get to that window, you go to Quick Access Toolbar. You go to Customize Ribbon. You click on this Customize Ribbon. Then when you click on the Customize Ribbon, you make sure that this developer checkbox, make sure that it's checked. The developer, make sure that it's checked. Then if it's checked, if it's not checked, you check it, then you click OK. Do you all see what I did? Or should I go over it again? How to go to the developer, how to bring out the developers tab. Okay, if you all guys see what I did to get there. Okay, I should repeat. Okay, let me repeat once more. Let me repeat once more because this is very important. So you go to the file. So when you get to the file, you click on options. So when you click on options, this box will appear. Then you go to customize ribbon. Then under customize ribbon, in this place, you make sure that the developer checkbox, make sure that it's checked. So if it's not checked, you make sure you check it. Then you click OK. So that's the way you get there. So when you click OK, in your developers, on your Excel window, you are going to see the developers icon or button. So if it is not checked, you will not be able to see this developer on your Excel. But if it's checked, the developers ribbon is going to show. Then you click on it. Once you click on it, you go to, once you click on the developers box, you go to Visual Basic because it's Visual Basic that you'll be using to write the code in Excel. Once the developer, let me go over it again. Once you've gone through that route to make sure that developer, you have this developers button on your Excel, you click on it, then you go to Visual Basic. Then when you click on the Visual Basic, because it's in the Visual Basic window, we are going to write the code. So I click on the Visual Basic window. So when you click on the Visual Basic window, you're going to see another window, which is this. So can you all see the Visual Basic window? The Microsoft Visual Basic window is when you click on it, it will automatically take you to this window. Can you all see it? All right. Okay. Thank you. So when you click on it, it's going to take you to this Visual Basic window. And is this Visual Basic window, that's where you're going to write the code. In order to create a module that you're going to write the code from, you're going to go to Insert. You go to Insert, then Module, because you want to write the code as a module. So you say Insert Module. So I click on it. When I click on it, the window, the code editor where you are going to write the window will pop up. The code editor where you are going to write the code is going to pop up. So we are going to write the code that is going to for the Eulers function. So I already have the code ready, so I will just paste it in this window. So in the notes, the code is in the notes. So if you want to do it on your own after the class, you can just copy and paste. So I would explain the code now. I will explain the code. Is it case sensitive? Yes, it's case sensitive. It's case sensitive. So thank you for that question. So what we mean by case sensitive is that, for instance, the name of this function is Euler. So if I had used small letter e, is different from using capital letter E. That's the meaning of case sensitive. So this is the function that is going to help us to do the Eulers method, and it's going to help us to do the numerical solution using the Eulers method. So in Visual Basic, you start with options explicit. So sorry, please, I lost network from the point where you selected Visual Basic. Okay. So actually, I don't want to go over it. I'm recording this meeting. So after the class, I'm going to send you the video of what we are doing so that you can do it yourself. So I don't want to go over it. So you are going to be, I'm going to show you, I'm going to upload the video of the meeting so you can just go over it again. So I want to explain the code now. So the options explicit. So when you are writing a Visual Basic code, it's just a syntax. You need to write this option explicit. So we have two functions here. We have the Eulers function. The name of the function is Euler. And we have this function, the y. So let me explain what both functions are doing. So the first function, which is the Eulers. So this is the way you define function in Visual Basic. You write function. Function is a keyword. You write function, then you write the name of the function. Then after that, you have some brackets. Then you include the parameters. The parameters are what you want to pass into the function when you are calling it. So I will be explaining that later. Then inside this function, we have two functions. This is the first function, the Euler's function. Then this is the second function, the y function. Let me explain this function first because it's much shorter. What this function actually does is just to calculate the model for us. Is to calculate v dot. Remember the model we are working with is v dot is equal to g minus c divided by m times v. This was our model. So we are just writing the model using mathematical or programming expression. So this is just the model. So what this function does, simply does is to calculate the expression of v dot. So v dot is equal to g minus c divided by m multiplied by v. So that's what this function is. And what you have here is just a definition of the variable. So you have g. Remember, g is the acceleration due to gravity. This is the way you specify it in Excel. So you specify g as 9.81 because it's a constant. Because it's a constant value, its value does not change. So we put the const keyword as double. Double being that it has decimal parts. If it was an integer, we'll just say as integer. But since the number has floating point values, that's why we say const g as double. So that's the way we do it in Excel. Sorry, ma, is the code affected by indentation? Okay, thank you for that question. It's not affected by indentation. It's not like Python. So thank you, Emmanuel, for that question. It's a very good question. It's not like Python, in which you have to, the indentation is important. The reason why I use the indentation is so that it will be clear. But for Visual Basic, the indentation doesn't matter at all. Okay. So this is to define the acceleration due to gravity as 9.81. So that's this function A, the y. Actually, we use this function inside the y function, which is the v dot, or the differential of the velocity A. So in this particular function, the Euler's function, we called this function, we called it here. You can see that what I highlighted here is the same thing as where my cursor is. So you can actually call a function within another function. So we call this function inside the Euler's function. So I've explained this function. This function is basically just your model. That's what it is. Then this Euler's function, what it does is just simply to use the Euler's formula. So all of this function, this is the most important of the whole of this function. And The reason why this is the most important is because this is the Euler's method. For the Euler's method, you said that your new velocity, y, is equal to the present velocity plus v dot multiplied by h, where h is the time step. So this is the actual formula or the equation that interprets or that represents the Euler's formula in Visual Basic Code. So this is the most important formula. The reason why we have this is that after we got the differentiation of the velocity v dot, because this formula here, this function returns the velocity v dot. It returns the velocity v dot. So once you have the velocity here, it's assigned to the y dt. So this, the y dt, represents v dot. Then h represents the time step. Then y represents the current velocity. So let me explain. I've just given a brief explanation of the Euler's function. So let me explain it. So these are the parameters. This is the name of the function. So when you're writing a function, you should have a name. So we name this Euler. So these are the parameters that's going to be passed into the function, so that when you are calling it, you must include these parameters. So in this place, we have 1, 2, 3, 4, 5, 6. We have 6 parameters. So when you are calling the function, you must include 6 parameters, otherwise it will give you an error. So within the function, we define some variables. We have h, we define this variable as double. We define t as double. We define y as double. And we defined the y dt as double. The reason why we are defining these variables is that we want to use it within the function. So we need to define it. Then these three lines, we assign ti. Ti is the initial time. Okay, let me explain the parameters you're going to pass into it, because when you are calling this Euler's function, you have to pass in some parameters. The first parameter you pass is the time step. So dt represents the time step. The second parameter you pass in is the initial time. So ti represents the initial time. The third parameter is tf, which is the final time. So tf represents the final time. The fourth parameter you're going to pass is yi. Yi is the initial velocity, represented by yi. Then the fifth parameter is m. M is the mass of the object, while the last parameter is cd. Cd is the coefficient of air resistance. So when you are calling this function, you have to pass in this function, these parameters. Then within the function, we define these variables. These variables, okay, can you allow for permission to record? Yes, you can record. You can record. I'm also recording. So I'm also recording. You can record. It's okay if you want to record it. And I'm also recording. So after the class, I'm going to post the video to you on Moodle so that you can watch it again and understand better. So if you want to record, you are very free to record. So let's continue. We assign the initial time to t, you assign the initial velocity to y, and you assign the time step, the t, to h. The reason why we are doing this assignment is that we want to use it within the function, and these variables are dummy variables, or they are local variables. When we are using it within the function, we don't want the function to change. So that's why we need to assign it to another variable name. That's why we have to do this. Then the next thing is this loop, this do loop. So what a do loop does is that it repeats the content that is within the loop. It keeps repeating and it keeps looping until a condition is satisfied, and that condition should be within the loop. And so that means that these expressions will keep on repeating continuously until a condition is satisfied, and that condition is given by this. So that condition says that if T is greater than TF. That means that if we've exceeded the final time, you know, TF is the final time. If we've exceeded the final time, then we should then exit do. So that means that you should go out of this do loop. So if this condition is not satisfied, the statements within this do loop will keep on, the statements within this do loop will keep on repeating until this condition is satisfied. So if this condition is satisfied, if T is greater than the final time, then you exit do. So this is the syntax you use. Then within the do loop, we have this if statement. So this if statement, it says if T plus the T is greater than TF, so it's greater than the final time. So that means that if you have already passed the final time, notice this is the initial time and this is the final time. For the Eulers formula, you need an initial time and you need a final time. For those of you that have done the assignment, you would understand what I mean by initial time and final time. So you need this. So if you've gone beyond the final time, what this statement is saying is that you should set H being the time interval to the final time minus T. That's what it's simply saying. And the reason why we have this if statements that I highlighted is that so that you don't go beyond the final time when you start the loop. That's what it simply means. Because when you say that H is equal to TF minus T, after executing this statement, it's going to execute this statement, which is V dot. It's going to execute this statement, which is the Eulers method. Then it's going to execute this statement, and H is equal to TF minus T. So if H is equal to TF minus T, that means T is equal to TF. So in essence, you've gotten to the final time. Then this statement is going to be executed so that you leave the do loop. That's why you have this statement here. Then the other, if T plus the T is not greater than TF, what is inside this if statement is not going to be executed. So it's just going to go to this line, go to this line, go to this line, then check for this. So that's the Eulers method. So like I said when I started explaining the Eulers method, this is the most important line here, because this line represents the Eulers method using the VBA programming language. So Y is the initial velocity, the Y dt is the V dot, and you got the V dot from this, and it's this function that is calculating the V dot. Then V dot here, this is our model, J minus C divided by N times V. Then this is the most important line here, and this is the most important line here. So you have, after you finished writing the code, you have to save. So when you try to save, can you see the pop-up on the screen? Can you all see the pop-up on the screen when I try to save? So when you try to save, okay, thank you. So when you try to save, there's going to be a pop-up on the screen, like you can see. And that pop-up is telling you that you are saving this Excel worksheet as a macro workbook. So this Visual Basic, you are including Visual Basic code into Excel, and it uses macro. So when you see this prompt, you have to click yes to continue saving to save a file with these features. Click no, then choose a macro enabled file in the type file list. So that means that after you are finished writing this code, you have to save it as a macro enabled workbook. So I will click on no. I'll click on no. Then can you all see my prompt of save as? So it will go to, you have to save it as Excel macro enabled workbook. Can you see the prompt as I'm saving it? Because it's very important. You have to save it. Can you see the prompt? Okay, thank you. Thank you. So when you want to save it, the default is Excel workbook. If you click on Excel workbook, it's not going to save the code you've written. So you have to click on Excel macro enabled workbook. You have to click on this. Then you go to save. Then it saves it as Excel macro enabled workbook. So after you've done that, you can now go back to your Excel worksheet. So after you've done that, you go back to your Excel worksheet. Then we have arrived at our Excel worksheet. Then in order to use the function, we already wrote the function, right? So we want to use the function now. So we click on this box here because we want to put in, I want to put in the value in this box. You click on this box, then you go to this formula box, then you write this function. This Euler was the Euler's function we created. Then you have the t. Yeah, the t being the time step. The t is the time step. The t is the time step. So this the t. This the t is highlighted in blue. So you can see the blue here. So that means that it's choosing 0.1 as the t. A9, you know, I told you that the first parameter is the time step. I told you that the second parameter is the initial time. So this 0 in blue, in green, sorry, is the initial time. Then the final time, you make it A10. So you said that let 0 be the initial time, let 2 be the final time. For those of you that have done the assignment, you will understand what I mean better because, like I said, Euler's formula, it uses the time step, it uses the initial time, it uses the final time, then it uses the initial velocity, then M and CD, they are just constants associated with the model. So the first parameter is the time step. The second parameter is the initial time. The third parameter is the final time. The fourth parameter is the initial velocity. And we represent the initial velocity as B9. B9 is 0 because that cell is empty. So it's 0. Then M is the mass. So mass is 68.1. Then CD is the coefficient of air resistance, which is 12.5. So you have 12.5 here. So after writing the Euler's method, remember we created this Euler method in that Visual Basic application. So you need to create it first before you can use it. If you've not created it, then if you do this, it's going to give an error. But since you've created it, so since we've created it, it's not going to give an error. So let me do it again. Sorry, it gave an error the first time. And that's because, so let me, it gave an error the first time because I actually made a mistake. So this is the box I'm supposed to click on. Then I write down the Euler's formula. So this is the t, this is the initial time, this is the final time. Then B9 is the initial velocity. The initial velocity is 0. So since there's nothing inside this box, it's going to evaluate as 0. Then the mass is this, then the coefficient is this. Then I just click enter. So it's now giving me an error again. So in order to do for the for this box, Excel is so good. You don't need to type the equation again. Just click towards the right hand side of the calculation you made previously, then drag it down. So it will automatically do the rest for you. So when you click on this, this is the time step. This is the initial time, A10. Then A11 is the final time. Then B10 is the initial velocity. So is going to be B10, initial velocity, then M and CD. So for this one, you have A11, here is A11, here is A12. Then the initial velocity is in B11. So this is B11 where my cursor is. So you have B11. So when you go down, it's going to keep updating for you. So one thing about Excel is that you don't need to keep on typing the formula for each of the box. You just drag it the way I've done it. You just drag it this way, the way I've done it. Then it will automatically update it. So the next thing I'm going to do, we've already done the numerical solution. If you compare it, so you have the numerical solution here, you have the analytical solution here. Can you see that the numerical solution it approximates better with the analytical solution? Here you have 35.8, here you have 35.6. Yeah, you have 41.3, you have 41.13. So it's because we are using a time step. So what I will do now is that I'm going to plot, in order to get the value of this box, what I'm just going to write, because the initial time is 0 for the first time step, the final time is 0, then the initial velocity is also 0. So it's just going to approximate to 0. Then I will plot it now. So, you guys should know how to plot in Excel. So you just select it, then you go to Insert, Plot, then it's going to give you this plot here. So let me try to change the legend. So let me label it. So I will select that time, then edit. So let me label it as V numeric. That's the numerical solution. V numeric, then MS squared. So let me add this analytical solution. Let me call it V ana and MS squared. Then the X value is from A9 to A11, A9 to A11. Then the Y value is from C9. So I'll change this one to C9 to C11. Okay. So you have the two solutions. Now we've plotted it and we can see that the initial solution. So let me change the legend. Let me just make it here so that it will be much clearer. So let me expand it, expand the plot. So you can see the plot. So blue represents the numerical solution, while red represents the analytical solution. The reason why you cannot see the blue is that the analytical solution is kind of the same thing with the numerical solution. So let me change it to, okay. So yeah, you can kind of see the blue line and the red line. So the red line is for the analytical solution, while the blue line is for the numerical solution. So one thing with Excel is that if you change the values, so now M is set as 68.1. Let me change it to 100. Once I change it to 100, you can see that the values immediately get updated and immediately the graph becomes updated. Let me change it back. Let me change this one to 14 or 15. So once I change it, you would notice that everything, the values becomes updated and even the graph automatically becomes updated. Let me change it back. Then now I was telling you about the time step. I was telling you that if the time step is much, it's going to make the analytical solution, the numerical solution, sorry, to be very far away. The error is going to be much. So let me make it 1. So you will see that the difference, can you see that the the numerical solution and the analytical solution is clearly visible now, then you can see the difference. So that's because the time step is very big now. So let me increase the time step further too. And you see that the difference between the numerical solution and the analytical solution is much more pronounced. So when we are making use of the AND calculation, when we are using AND calculation, we have to use a very large time step so that you don't do lots of calculation. But if you use MATLAB or Excel to do it, so let me change it to 0.1. It's going to make the calculation to be faster, and it's going to make the error, because you are using a computer, is faster. And because you are using a smaller time step, the error, the difference between the analytical and numerical solution is much smaller. So in the next class, we will talk much more about the error between okay, ask your question. Somebody wants to ask a question. You can ask your question, please. So using Excel is graphical. So the graphical feature of Excel, and the fact that it updates anytime you change a value, you can update it very quickly. It makes it better than Excel. So your question is, when the time step is much smaller, is it much accurate? Yes, it's much accurate when the time step is much smaller. So now, let me just indicate again. Now, the time step is 0.1. Can you see that we cannot even see a difference between the analytical and numerical solution? So let me make it 2. Now, the time step is bigger now. Now, there's a big difference between the analytical and numerical solution. If I make it the time step much bigger, the time step, the difference is going to be much more pronounced. Let me make it 10. So you can see that if the time step is bigger, the error between the analytical solution and the numerical solution is much smaller, is big. The error is very, very much. But when I use a smaller time step, let me say 0.1, you can see that the error is even almost negligible from the graph. And if you look at the values, the error is almost negligible. So I have less than 1 minute to go. So I would